everyone. Our function f of x equals x squared minus 4 is defined over our interval 2, 6. We're going to use the trapezoid rule and approximate the area by partitioning 2 and through 6 into 4 subintervals and into 8 subintervals of equal length. And we're going to choose u as our left endpoint. And then we're going to express the area. A is an integral. And also, my class, we've already gone over this. We're also going to evaluate that integral. So I kind of did the drawing here. And so the first part, we need 4 subintervals. So if we take 6 minus 2, and we want 4, so this is going to be 4 divided by 4 equals 1. So our unit is 1 here. We're going by ones. Now, if you want to draw the graph, so there's our graph, and we have to start as our left endpoint, and we have a total of 5 endpoints. So we're starting at 2. 2 is the left endpoint. So we're going really basically from 2 to 5, because we need 4 endpoints to do this. So at 2, there's no place to go up. So we're going to start at 3, graph to this, graph here, then go to 5. And we're just drawing these little triangles in here. So that's what it looks like for 4 intervals. So what you're going to do is use the formula, and since our unit is 1, we're going to do our area is f of, we start at 2, and then we're multiplying by 1. All right, plus f of 3 times 1 plus f of 4 times 1 plus f of 5 times 1. I can't write that. F of 5, times 1. So since we're just multiplying by 1, you just have to find f of 2. So f of 2 is 0. Times 1 is just 0. F of 3 is 5 times 1 plus f of 4 is going to be 12. And then f of 5 is 21. You add this up, we get 38. So that's our approximate area. Now I'm going to duplicate this page. It's going to look like I'm going to erase a lot of stuff, but it's still going to be here because I'm duplicating it. But you're not going to be able to see that on the screen. So if you need to scroll back, you can. So I just duplicated it. And now we're going to do the second part with the 8 subintervals. So basically that means we're going from 6 to 2. So 6 minus 2 divided by 8. And that's just going to be 4 over 8, which is 1/2. So we're going by 1/2. Now I'm going to take this same graph, and we're starting at 2 as our endpoint. Then we have 2.5, 3.5, 4.5, and 5.5. And to graph, to start with this, you would kind of add in here. Then we're adding this, going up to here. So I'm kind of combining the graphs to save little time. And f of 5 is going to go up here. So that's going to go like that. So if you can kind of see it that way, that's basically your graph. If I could all do it in red, let's see if I can do all this in red. So then this would go down. I'm just doing it in red. And then you could take out these lines with the purple in them. So I'm going to erase that without messing up too much. Anyway, I hope you get the idea. You're going to erase those purple horizontal lines. And that gives you the graph. So basically we're doing the same thing. We're starting, they want the left endpoint. So we're starting with our area and we're approximating it. And that's going to be f of 2. And now we're multiplying by 1/2. Plus f of 5/2 times 1/2. Plus f of 3 times 1/2. Plus f of 7/2 times 1/2. Plus f of 4 times 1/2. Plus f of 9/2 times 1/2. Plus f of 5 times 1/2. Guess I'm writing too big. Plus f of 11/2 times 1/2. Now, figuring all that out, you're going to get, I'm going to erase this. This is going to be 0 times 1/2 plus 9/4. Let's just go ahead and pull out the 1/2 first. All of these have a 1/2 in it, so I'm just going to pull out the 1/2. So then when you pull out the 1/2, you're just going to get 0 plus 9/4 plus 5 plus 33/4 plus 12 plus 65/4 plus 21 plus 105/4. And then multiplying all that through, I already did this part. That's going to give you 0 plus 9/8 plus 5/2 plus 33/8 plus 6 plus 65/8 plus 21/2 plus 105/2 or eighths. Now this is going to equal 91 divided by 2, and that's going to give you 45.5 as approximate area. So this one's probably a little more accurate than the first one we did. Now we're going to write this as an integral. So to write this as an integral, we're just going to write the integral sign, and we're going from 2 to 6. You copy down this x squared minus 4, then write dx. Now we're going to use the evaluation theorem. Take the antiderivative. If you haven't got this far yet, then you could probably skip this part. My students have, so we're going to continue on with that. When you find the antiderivative of this, it's going to be x cubed divided by 3 minus 4x. And then we're evaluating this from 2 to 6. And since we found our f, our antiderivative, then we're going to do f of 6 minus f of 2. So f of 6 is going to be 6 cubed divided by 3 minus 4 times 6. And then minus, and then we do f of 2. So that's going to be, this one's a little easier, 8 cubed minus 8. All right, 6 cubed is, let's see, double check, 216 divided by 3 minus 24 minus, and our common denominator is 3, so this is 8 thirds minus 24 thirds. All right, and you can put that in the calculator, and you're going to get 53.33 repeating. So that is your area under the curve. And that's it. Thank you. Have a nice day. Bye-bye.